Welcome to the session number 18 from the playlist of electromagnetic induction. The topic is the combination of inductors. So in this session, I will be discussing about the series and the parallel combination of inductors. Now in the first point, I have written that the inductors can be arranged in series and the parallel combination, and they can be placed near to each other or they can be placed far away from each other. So in the series combination, there can be two cases. First one when they are placed near to each other, and the second one when they are placed far away from each other. So when the two inductors are placed near to each other, then their equivalent inductance will be equal to L1 plus L2 plus minus 2M. Now here L1 and L2 are the self-inductance of the two coils, and here M is the mutual inductance. Now here I have written in the formula that is L1 plus L2 plus minus 2M. Now the equivalent inductance will be equal to L1 plus L2 plus 2M when the magnetic field of both these two inductors are aiding each other, and the equivalent inductance will be equal to L1 plus L2 minus 2M when the magnetic field of these two inductors are opposing each other. Now when these two inductors are connected in series but they are placed far away, then in that case the mutual inductance will be 0, and so in that case the equivalent inductance will be equal to L1 plus L2. Now let's come to the third point, that is a parallel combination. Now in the case of the parallel combination, there will be two arrangements. First arrangement is when the inductors are placed far apart. So when the inductors are placed far apart, then the equivalent inductance will be equal to 1 upon L will be equal to 1 upon L equivalent. This is equal to 1 upon L1 plus 1 upon L2, and L1 and L2 are the self-inductance of the two coils. And this formula is when two inductors are connected in parallel to each other and placed far apart. And when the two inductors are connected parallel to each other and placed near to each other, then there will be two cases. First one is when the magnetic field of the two inductors are aiding each other. So when the magnetic field of the two inductors are aiding each other, then in that case the equivalent inductance will be equal to L1 into L2 minus M square divided by L1 plus L2 minus 2M. Here M is the mutual inductance and L1 and L2 are the self-inductance of the two inductors. And when the magnetic field of the two inductors are opposing each other, then in that case the equivalent inductance will be equal to L1 into L2 minus M square divided by L1 plus L2 plus 2M. So here we can see that the equivalent inductance is more in the case of two inductors which are combined in which are arranged in parallel, and their magnetic field are aiding each other. When the magnetic field are opposing each other, then in that case the equivalent inductance will be less than the equivalent inductance in the case when the magnetic field of the two inductors are aiding each other. So from here, if I this value, that is the equivalent inductance of the two inductors connected in parallel, and when the magnetic field of the two inductors are aiding each other, this will always be greater than the equivalent inductance of the two inductors which are connected in parallel and when their magnetic field are opposing each other. Then in that case, this is the formula for it, and this value will always be less than this value. So thank you very much for joining this session. In the next session now I will be coming up with a question which will be based on this topic, that is combination of inductors. So till then, have a nice day. Bye.